and I'm going to embed the actual graph of the function there too. So you'll see what the graph looks like. You don't have to create the graph yourself. But what you have to do is figure out, based on the rules that we just saw, where are your vertical asymptotes and your holes going to be located. Okay, so when you look at the toolboxes that are going to be present for these types of questions, you're going to see these three. Okay, this is the line tool. You're going to use that for the vertical asymptotes. This is a closed circle. This is an open circle. Which of these do you think you're going to use for the holes? Yeah. So your open circle is where you're going to use for the holes. Okay, and there's a tolerance to the location of the hole. Okay, and so you're going to put it on the graph at the x coordinate that you are looking to identify. So when we look at this first function, and these are written in factored form so you can identify. Okay, when you look at this, do you have any factors that cancel? Yes. Yeah, the x minus 1's cancel, right? So when you're looking at your function, you only have one factor remaining in your denominator, so that creates the vertical asymptote. So you're going to have a vertical asymptote at x equals what? 6. So you're going to draw, and it won't be a dashed line on yours, but I'm going to draw it as a dashed line here. And you're going to draw in your vertical asymptote, and then if you need to, you're going to place a hole. So in this case, where's the hole going to be located? A hole at x equals 1. So you're going to take this open dot, you're going to go to 1, and where I see 1, you're going to click on the graph itself. So you'll place that hole directly on the graph. Again, this is not the x-intercept. It's a hole, an open circle that you place on your graph. Okay? So there's two discontinuities here. Your graph extends here. It breaks, starts new here, and it breaks right at this spot and then continues here. So there are breaks. That's why these are called discontinuities. Okay, so I'm going to talk through this second example too. Again, if you have a copy of it on your iPad or if you printed out a copy, you can do it really quickly, but you're probably not going to sketch this precisely. Okay, so when you look at this second problem, are there any factors that cancel? No. So what we know is there's no holes. Okay, the holes exist when the factors cancel. And you're going to have vertical asymptotes at what? X equals -3 and 2. Now, you should be able to see these in your graph as well. So here I see what I'm dealing with. Here's one vertical asymptote. Here's the other. I'm going to use my line tool to sketch those in, and that's what you're going to be asked to do.